All right, hey guys, so we're working on 12-6 coordinates in space. At this point in time, this is part 2. You should have watched the video from YouTube that I posted on the first part, which gives you a lot better display showing you what a three-dimensional figure looks like, okay? And so we'll look at some of the assignment, and then we will go and I will finish the lesson, all right? So this assignment is homework number all right, so should be homework number 14. Which is number 18 through 36. On page 684. And it's awkward writing across in front of the computer here. But. All right, so let's look at it. So number 18 through 20 says plot each point in a three-dimensional coordinate system. So just do the best you can. Don't worry about that. Based on the video, just draw me some sort of a graph for each one of those and try to give me your best shot at a three-dimensional coordinate system using a box or whatever. All right. So as long as you give me a good effort, you're going to get credit. All right. Okay, 21 through 26 is also from the other lesson. It says determine the distance between each pair of points and determine the coordinates of the midpoint. All right. So the distance, so we'll do one of these together. Okay, so 21, the points are A, J, and K. So we want to find length J, K. All right. Which is going to be the difference in X value squared plus the difference in Y value squared plus the difference in Z values squared. All right. Okay, so point J is 3, -7, and 0. That's 3, -7, and 0. And then point K is 5, 1, and 7. So 5, 1, and 7. So 3 minus 5 is -2. -7 minus 1 is -8. And 0 minus 7 is -7. So -2 squared is 4. -8 squared is 64. -7 squared is 49. So 64, 104, 117. So that would be the square root of 117 would be the exact answer. And if you go to your calculator, that's approximately 10.8 units, okay? All right, distance from the only distance is difference with adding that third point, all right? Okay, and then midpoint, and he made a little bit of mistake in the video. Midpoint formula, the whole thing is in parentheses. He messed up the X's, the Y's, and the Z's, and he put the parentheses around here, here, and here, but the whole thing is a point, so it's around parentheses. So again, point J was 3, -7, 0. So 3, -7, 0. And point K is 5, 1, and 7. So 5, 1, and 7. So 3 plus 5 is 8. Divided by 2 is 4. -7 plus 1 is -6. Divided by 2 is -3. 0 plus 7 is 2 is 7. Divided by 2 is 3.5. So the midpoint is 4, -3, and 3.5. And that's how you do 22 through 26. Again, show me the numbers plugged in. And then once you show me the numbers plugged in, you can go to the calculator and however you want to do it, come up with the answer. All right. So distance and midpoint, all right? Okay, now let's look at 27 through 31. 27 through 31 says identify each of the following as true or false. If the statement is false, explain why, okay? All right, 27 says every point on the YZ plane has the coordinates C, Y, and Z or any real number. Okay, if it's on the YZ plane, and that means that x equals 0. So it's actually going to be 0, y, and z. So it's false, okay? And all that is your explanation as to why it's false. All right. All right, so 28, we're going to stop and go back and finish the lesson, all right, which is on page 682, which you didn't talk about, okay? All right, so the equation for a sphere, circle, remember was x minus, circle is x minus h squared plus y minus k squared equals r squared. For a sphere, we're just changing some different letters, okay? X minus I squared plus y minus j squared. And now we're going to add a z factor, which was not there before. And that's going to be z minus k squared, and it still equals r squared. Okay, so once again, as in the distance formula, the midpoint formula, and now the formula for the equation of a sphere, you're just adding the third element for the z coordinate. Okay. All right, so let's go back to the lesson, okay? My grandson is having fun watching his videos, okay? Strange as it sounds, that's happy sounds, okay? All right. Okay, so let's go back. 28 says, the point at 1, 8, negative 12 is inside the sphere, all right? So basically, this is a little bit tricky, but essentially we need to know what that looks like, okay? So basically, if we did our coordinates, I'm going to show you work, okay? So remember, this is y, this is z, and x is out here someplace, okay? So if you look at the equation is x minus 3, which means the x value is 1, 2, 3, and y minus 5, so the y value is 5, 1, 2, 3, 4, 5, and then z is z plus 2, so that's actually negative 2, so the z value is negative 2, right? So that means my center of my sphere, if you draw your box, then that means I'm out from the board 3, I have the right 5, and I'm down 2. So somewhere in here is the center, and is r squared is 9, so r equals 3. So I go 3 from any direction. So basically, another way of looking at it is I can go 3 plus or minus 2, and I can go 5 plus or minus 2, and I can go 2 plus or minus 2. And the point they gave was 1, 8, and negative 12. Well, 1 is plus or minus 2. 8 is not plus or minus 2. So it's outside of that, okay? So therefore, this is false. And all those things can be your work, okay? All right. Okay, 29. The intersection of the XY plane, the YZ plane, and XZ plane is a point at 0, 0, 0. That's true. That's the origin. So all you got to do is write true for that one. All right. 30. The set of points in space 5 units from the point 1, negative 1, and 3 can be described by the equation. All right, so in that case, if it's 5 units from that point, then r squared equals 5 squared, which is 25. That's what the equation shows. And then 1, negative 1, and 3, that would be x minus 1 plus y minus negative 1 plus z minus 3 equals 5 squared. So that's x minus 1 plus y plus 1 plus z minus 3 equals 25. And that is the equation, and therefore that's true. Okay. All right, my blue is starting to wear out. I got to switch to red, I guess. All right, 31. A set of points equidistant from point A, 2, 5, and 8, point B, -3, and 4, and 7 is a line that is the perpendicular bisector of segment AB. Well, if I have a point A and a point B, then the set of points in a plane in space is a plane, okay? This becomes, let's just write that, becomes a plane in space, all right? Becomes a plane in space, and therefore it is false, okay? All right, that brings us to 32 through 35, okay? Which says determine the coordinates of the center and then measure the radius for each sphere whose equation is given. All right, I'll show you how to do that. We'll do 32. All right, so we've got x squared plus y minus 3 squared plus z plus 8 squared equals 81, all right? So this is really x minus 0 squared. So that gives me 0. And this is y minus 3, so that gives me 3. And z plus 8 is z minus -8. So that gives me -8. And the square root of 81 is 9. So the question was determine the coordinates of the center. Well, the center is 0, 3, and -8. And the radius, so in this case, the radius is 9, okay? And that's how you do 33, 34, and 35. Okay. All right, 36, just the opposite. Write the equation of the sphere using the given information. All right, so they gave us a point of -5, 11, and -3, and the radius is 4, so this becomes x minus -5 squared plus y minus 11 squared plus z minus -3 squared equals 4 squared. So my equation becomes x plus 5 squared plus y minus 11 squared plus z plus 3 squared equals 16, okay? And that's the answer to 36, and that's as far as we're doing. So you got stuff to finish on your own. This finishes the chapter. At some point in time, I'll give you the test review, and we'll also start the next chapter. We'll start chapter 13 before we actually take the test. All right, enjoy. Contact me with questions.